The times we live in are truly and without doubt fascinating. In the past several hundred years, people have learned to travel comparatively fast on land and water, and more recently have even managed to fly to some space objects near us. However, a proper space tour remains a dream rather than becomes a real possibility right now. And so I invite you to join me on a virtual tour. In the course of our little trip, we will fly by the most amazing objects in the nearest parts of our universe at the speed of light. We will set off at the orbit of Ceres, then we'll go as far as Orcus and pass some really bizarre stars on our way further and back. Fasten your seatbelts, let's go! Cosmo, the first in outer space. An object with these properties is Ceres, the second smallest dwarf planet within the solar system after Hygeia. Until recent past, it used to be considered the smallest dwarf planet in our system. Ceres was discovered back in 1801 by the Italian astronomer Giuseppe Piazzi and used to be considered a fully fledged planet of our system for a long time. However, in 2006, this celestial body was eventually classified as a dwarf planet. With a diameter measuring approximately 950 kilometers, Ceres is the largest and the most massive body in the asteroid belt. It also beats many satellites of giant planets in terms of size. The diameter of Enceladus, for instance, is twice as small, measuring 504 kilometers. Ceres' mass accounts for almost 32% of the total mass of the asteroid belt. It was possible to determine this following the analysis of the object's influence on other, smaller objects in the belt. According to the average value of three most accurate estimates made by 2008, Ceres' mass is considered to be this: 9.4 multiplied by 10 to the power of 20, or 1.3% the mass of the Moon, or else almost 6,000 times as little as the mass of our planet. Even though Ceres is 3.5 times smaller than the Moon, the contrast of their masses is stark, but the reason lies in the fact that they differ in their chemical composition, as our Moon is made up mainly of hard rocks. Ceres has a spherical shape, which is untypical of most other small celestial bodies. It assumed this shape due to the influence of its own gravitation. This is the major difference between Ceres and large asteroids like Pallas or Juno, which are not spherical in shape. The object's area is 2,849,631 square kilometers. Just to compare, it is slightly bigger than Argentina. Unlike with other asteroids, a special feature is peculiar to Ceres. After it assumed a spherical shape, there started gravitational differentiation of rocks in the object's interior. Briefly explained, it's a process when heavier rocks shift to the core with lighter ones forming an outer layer. Thus Ceres came to possess a rocky core and a cryomantle made up of water ice. The mantle is 100 kilometers thick and accounts for 23 to 28% of the object's mass, as well as for half its volume. In addition, it contains about 200 million cubic kilometers of water in the form of ice, which is more than there is fresh water on Earth. Speaking about the formation process of this dwarf planet, it is assumed that Ceres' core could have been heated up as a result of radioactive decay in the first stage of the asteroid's life. At the same time, some part of the icy mantle may have been in the liquid state at the time. It looks like the surface is still for the most part covered with ice or some kind of icy surface regolith. The question of cryovolcanism on Ceres still remains open too. Following analysis of data collected by the Dawn probe, the largest mountain on Ceres, for instance, called Ahuna Mons, is an icy cryovolcano. This is evidence that the dwarf planet has been geologically active for at least the last billion years. For all we know, Ceres may well be active right now. Seen from the Earth, Ceres is rather dim and its visible disk is extremely small. That is why finer details were distinguished on it only at the end of last century with the help of the Hubble Space Telescope. there is a number of light and dark spots to be seen on the asteroid's surface, which appear to be craters. The brightest one of these has been dubbed Piazzi. Probably this spot is a crater spilling some of the icy mantle, or perhaps showing a cryovolcano. Further observation of the object in the infrared range revealed the average surface temperature, which is 167 degrees Kelvin or 106 degrees Celsius below zero. Thanks to the observations of the dwarf planet in the radio spectrum, it was ascertained that Ceres' surface is quite smooth. Come to think of it, it is hardly surprising, as the icy mantle should be quite elastic. Telescopic investigation has remained the only observation method employed to study Ceres until 2015. Thus, water vapor clouds around the object were spotted in January 2014 thanks to the Herschel Infrared Space Telescope. This is how Ceres came to be the fourth celestial body in the solar system with registered water activity. The other three are Enceladus, Europa, and of course our Earth. The Dawn Interplanetary Space Probe, launched in 2007, heralded the most momentous stage in studying the dwarf planet. Having drifted in Vesta's orbit for a while, Dawn proceeded to make the acquaintance of Ceres, and on the 13th of January 2015 it captured the first detailed images of the asteroid's surface. On the 8th of February, the probe was just some 118,000 kilometers away from the object, heading towards it at a speed of 360 kilometers per hour. On the 18th and 25th of February 2015, NASA published detailed pictures of the dwarf planet where two bright white spots are clearly seen. The spots were later identified as supposedly the chemical element sodium carbonate, also known as soda. Dawn went on to enter the asteroid's orbit on March the 6th, where it was to stay for the next 16 months to carry on observation. It is in this period that it was able to take images of the puzzling white spots, and to this day these photos are the best we have of them. The probe's mission was over on June the 30th, 2016. The data beamed back to the Earth helped estimate the dwarf planet's mass and size, and also provide hard evidence of there being water ice on the planet's surface. And it is likely to be found inside the craters. 634 such craters have been spotted in the northern polar area of Ceres, 10 of which contain deposits of bright material. Ice formation has been spectroscopically identified in one of them. Spectra in 2015 revealed no water, but revealed presence of hydroxyl-rich materials and a somewhat weaker streak of ammonium. It is likely to be ammonia-rich clay, where water is chemically bound and comes forth as hydroxyl. Thanks to the data revealed by the Dawn probe, it was possible to make certain conclusions about the craters. Since the number of large craters is smaller than expected, it is logical to assume that the surface undergoes gradual changes. As a result of all studies that have been carried out, it is suggested that water vapor is likely to account for 20 to 30% of Ceres. Apart from that, various hydrous minerals and substances may be found in the surface composition, carbonates and clays rich in iron. Ceres hasn't been discovered to have any moons. Based on observations using the Hubble telescope, it is safe to say that even if there are any moons, they cannot be over 20 kilometers in diameter. But be it as it may, the history of studying this space object isn't over yet. In the next decade, the Chinese National Space Administration, or CNSA, is planning to take soil samples from the dwarf planet's surface. Ceres is often associated with another large object in the asteroid belt. The celestial body in question is called Vesta and is considered to be the largest known asteroid in terms of size and mass. In fact, Vesta is clearly seen even with the naked eye from our planet's surface. Its parameters are 578 by 560 by 458 kilometers. Were it not so asymmetrical, it would also be classified as a dwarf planet, as it would then qualify to be called one according to the updated classification of the solar system objects. The combined mass of Vesta and Pallas, another large asteroid, is half that of Ceres. At the same time, Vesta is 25% heavier than Pallas. The surface temperature on Vesta fluctuates between 106 and 3 degrees Celsius below zero. And here is a picture of both Vesta and Ceres taken by the Curiosity Mars rover in 2014. Several decades ago, an object like Ceres would pose quite a riddle for scientists. Today, however, we're able to speak with relative certainty about its makeup, chemical composition, and history of formation. The Kuiper Belt is an area in the solar system stretching from Neptune's orbit to a point 55 astronomical units away from the Sun. In many ways, it resembles the asteroid belt, but in contrast, the Kuiper Belt is 20 times as wide and approximately 100 times as massive. For the most part, it is made up of small bodies, basically debris of material left after the formation of the solar system. Unlike the asteroid belt objects, celestial bodies in the Kuiper Belt consist for the most part of volatile elements like methane and water. There are at least 4 officially confirmed dwarf planets in this area, and it is here that Orcus was discovered. The object was spotted on the 17th of February 2004 by American astronomers Michael Brown, Chad Trujillo, and David Rabinowitz. The scientists were able to distinguish it in some archive images taken back on the 8th of November 1951. Now let's take a closer look at it. Orcus is a large trans-Neptunian object of the Plutino category. Apart from Orcus, other celestial objects of this category include Pluto, Ixion, and Huya. Objects like that are locked in a 2 to 3 resonance with Neptune, which means that when a Plutino orbits the Sun twice, Neptune orbits it 3 times in the same period. The furthest point from the Sun regularly reached by Orcus is 48 astronomical units, and the closest it ever gets to the Sun is 30 astronomical units. Orcus's diameter supposedly measures 946 kilometers, which is approximately 40% that of Pluto. Its surface temperature is 229 degrees Celsius below zero. It is largely thanks to Orcus's moon discovered in February 2007 that scientists are able to have clearer ideas about Orcus's properties. The discovery of the moon was Michael Brown's achievement too, and the object was dubbed Vanth. It takes Vanth 9.5 days to complete one full orbit around Orcus. The distance between them is 9,000 kilometers. It is posited that Orcus and Vanth are in synchronous rotation. That is, they face each other at all times with the same sides. Pluto and its satellite Charon are locked in the same manner. Vanth's diameter is estimated at approximately 280 kilometers, and the object's orbit around Orcus is practically circular. However, these parameters for both Vanth and Orcus are still admittedly not very accurate at this point. Vanth's mass may account for 3 to 7.5% of the total mass of both objects. As we've mentioned before, Vanth is just 9,000 kilometers away from Orcus, which is too close for its surface composition to be spectroscopically analyzed. It is suggested, however, that Vanth may have been captured from the Kuiper Belt at some point. The total mass of Vanth and Orcus is 3.8% that of Eris, one of the most massive dwarf planets known today. But the way the mass is distributed between Orcus and its satellite depends on the ratio of their sizes. Investigations of Orcus's spectrum found that the signal absorption by water ice there is the strongest among Kuiper Belt objects not related to the Haumea family. Large Uranian satellites have a similar spectrum. Among other trans-Neptunian objects, it is Charon, Pluto's satellite, that resembles Orcus the most. They have similar density, and water ice was detected on the surfaces of both. Orcus's spectrum differs a lot from that of other trans-Neptunian objects. Red is to be found in Ixion's spectrum, for example, but infrared there is rather faint. Orcus's visible spectrum is of a neutral faint hue. Further infrared observations of Orcus confirmed that there is water ice and carbonaceous compounds in its composition. The parameters of Orcus's orbit make one think of those of Pluto. In the past 14,000 years, the distance between Orcus and Neptune has never been shorter than 18 astronomical units. And even though Orcus's orbit almost brushes that of Neptune, the strong tilt does not allow the objects get closer. The rotation period of Orcus still remains to be found out. Photometric studies give rather scattered results, from 7 to 21 hours. Now let's take a look at its surface, which is comparatively bright. The ice discovered on it is for the most part in crystals, which may be indicative of cryovolcanic activity. Other compounds like methane or ammonium may also be found on Orcus. Interestingly, to date, ammonium hasn't been discovered on any trans-Neptunian object or ice moon save Miranda. In addition, models of internal heating by thermonuclear fusion suggest that Orcus is able to sustain a subsurface ocean of liquid water. Since there are water ice crystals and possibly ammonium ice to be found, it may be indicative of renewal mechanisms that may have been active on Orcus's surface in the past. Cryovolcanism may well have been one of these mechanisms. A single eruption may have taken place on Orcus at some point, turning amorphous water into ice crystals. As for the origins of this celestial body, scientists are still at odds trying to find an answer to this question. According to Amy Barr and Meg Schwamm, Orcus may have been formed when some celestial objects collided at a low speed. There are also doubts as to what category Orcus falls into. Today, Orcus is a possible dwarf planet, but this is just a suggestion that may potentially be disputed rather than a unanimous opinion. Apart from Orcus, there are at least 40 other similar dwarf planet candidates known to science today, and according to preliminary estimates, the number of possible dwarf planets in the entire solar system which haven't been discovered yet may well exceed 2,000. The number of officially acknowledged dwarf planets today is 6. These are Ceres, Hygeia, and trans-Neptunian objects Pluto, Eris, Makemake, and Haumea. And if you would like me to tell you more about these, please let me know in the comments below. To qualify as a dwarf planet, and to get on the list of the acknowledged ones, Orcus has to satisfy certain parameters. Namely, astronomers have to make sure that firstly, Orcus orbits the Sun. Secondly, that its mass is sufficient to maintain a spherical shape. Thirdly, that it is not any planet's satellite, and last but not least, that it is not able to get rid of debris it may come across in its path. At this point, Orcus comes fourth on the list of likely dwarf planets, beaten only by the following celestial objects: Gong-Gong, Quaoar, and 2002 MS4. Let's look at them in order. Gong-Gong is one of the largest trans-Neptunian objects, and it was discovered on the 17th of June 2007 by Michael Brown's team. Its diameter supposedly measures 1,535 kilometers. Its mass is 75% bigger than that of Ceres and is only slightly bigger than that of Quaoar. It has a moon called Shangliu in its orbit, which is 15,000 kilometers away from it and whose diameter is 300 kilometers. Quaoar is a trans-Neptunian object too, which may rightfully be called one of the largest in the Kuiper Belt. Just like Gong-Gong, it was also discovered by Michael Brown's team, and it happened the same year that 2002 MS4 was added on the astronomical map. Quaoar's diameter is estimated at approximately 1,100 kilometers. It has a moon in its orbit with a diameter of 74 kilometers named Weywot. 2002 MS4 is the third likely dwarf planet candidate, and according to some estimates, it boasts a diameter of about 930 kilometers. All these celestial bodies, including Orcus, may be considered rather large for ones in the Kuiper Belt. Their parameters lead scientists to think them very likely to be dwarf planets, which may mean that one of them will probably be officially granted this status very soon. It is also highly likely that it is Orcus that will make this new dwarf planet in the solar system. But while it isn't the case yet, this celestial object remains to be figured out, and its further exploration may reveal new exciting evidence that is still lying in store for us. interstellar travel has always been one of mankind's cherished dreams. Over half a century has elapsed since the launch of the Earth's first artificial satellite, and since then terrestrial spacecraft have covered truly record distances on escape trajectories from the Earth. The Voyagers were among the pioneer spacecraft to set out in space, with their top traveling speed reaching 62,140 km per hour. Juno is the second superfast space probe worth mentioning here, which approached Jupiter at 250,000 km per hour. As for the recently launched Parker Solar Probe, it is able to propel itself at up to 700,000 km per hour. As a rule, the speed of such spacecraft is generally attained with the use of gravity boost maneuvers. That is when a spacecraft enters into an object's orbit, which helps increase its speed. This trick works well within our system, but be it as it may, in order to travel as far as stars, scientists will have to think of other strategies, as there may not be enough celestial objects on the spaceship's way through interstellar space which would help to perform gravity boost maneuvers. It is quite possible that in the future, terrestrial spacecraft will be able to reach the ultimate speed for traveling around the universe. However, to date, only light is able to travel that fast. Its speed is traditionally considered the limit and is a constant at 299,792,458 meters per second. Any particle with a mass will never reach this speed, and any particle without a mass will always travel at this exact speed in the vacuum. The concept of an engine which would be able to exceed the speed of light has long been considered preposterous in scientific circles, while considering flying to neighboring stellar systems was completely out of the question. But as time goes by and with sufficient global knowledge, the most audacious ideas may prove realistic. Thanks to being widely promoted by science fiction films, the Warp Drive became the first project of this scale. The history of its development goes back to 1994, when Mexican scientist Miguel Alcubierre assumed that the concept of traveling at superluminal speeds could be considered as Einstein's equation solved in theory. The equation defines the relation between space, time, and energy in our universe. In plain language, in his theory, the Mexican scientist puts forward the idea of traveling in the manner when a spacecraft is cocooned in a bubble of space. The warp drive inside it makes the space in front of the bubble contract and the space behind the bubble to expand, with the spacecraft in between remaining motionless. Thus, the bubble is able to travel together with the spaceship at an unlimited speed which beats even the speed of light. This travel could be compared with moving on a surfboard, with the surfer remaining motionless and the board propelled forward by waves. At the end of last century, this idea could seem pseudo-scientific, but due to a loophole in physical laws, this may be manageable. It isn't the object that is moving, but the space around it, and space is capable of traveling at greater speeds than light. By and by, still more space-time properties were discovered by science, and many scientists were attracted by the concept of the warp drive. In 2007, thanks to the Gravity Probe B project, the ability of space to get warped in the vicinity of massive objects was proved once and for all. In 2015, thanks to the LIGO Observatory, the first gravity waves were detected in the form of space-time perturbations, which may be described as ripples in space. As recently as in August 2008, dozens of science groups were offered by the Ministry of Defense of the United States to look into prospects of exploring new aerospace technologies. A report on a warp drive was the most striking of the presented papers. Its authors argued that the creation of the warp drive would be closely linked with studying dark energy, the force that makes the universe expand with an accelerating velocity. At the time, the report prompted a lot of debate among dark matter and energy specialists. However, 10 years later, the idea of a warp jump was brought up again. In 2019, American engineer Joseph Agnew revealed the results of his work where he was able to break down the theory of the warp-jump propulsion force into simple, comprehensible bits. According to the scientist, the warp deformation can be unleashed by means of space-time contraction and expansion, which would be aimed in a specified direction at a specified time. Today, the emergence of such technologies seems unthinkable, but even now, scientists are aware of the fact that high-density energy is able to cause a necessary warp in time-space. In the future, science will most likely have to advance technologies generating such energy forms to the ultimate level, which means that only in decades will these experiments yield results. Apart from the futuristic warp drives, however, there is a great number of projects which are not less exciting and more down-to-earth, as it were. The Ion Thruster is one of them, with several organizations currently working on it. The general principle of its work lies in ionizing gas and accelerating it with electrostatic field. Since ions have a mass, they can be accelerated, which will produce the thrust. The ion thruster contains some gas which is ionized with a gas charge, where gas atoms with a neutral charge are split into negative electrons and positive ions. After that, ions are accelerated by an electric field in a sophisticated system of grids. This same system blocks the movement of electrons. On leaving the nozzle, positive particles are neutralized by negative electrons so that the ions do not go back to the drive and do not impede its thrust. In theory, this method allows accelerating ions up to 210 km per second, which is considerably higher than the speed of particles in chemical rocket jets used in all contemporary space and military rockets. Their speed reaches just 4 km per second. At the moment, existing engines of this kind lack in power and are applicable only for adjusting the orbit's trajectory. However, if future scientists are able to create a more powerful version of the ion thruster, it will allow spaceships to reach the surface of Mars in just 39 days, which is approximately 7 times as fast as the current optimal travel time it takes to get to the Red Planet. Another possible option that may present itself for traveling to the neighboring celestial objects will probably involve nuclear rocket engines. The principle of their work will lie in a source heating up as a result of the decay of radioactive material. This approach was tested at the beginning of the space age, but so far it has been inapplicable due to 2 factors. Firstly, the use of these technologies would lead to harmful emissions of large amounts of radioactive waste into space. Secondly, the nuclear engine requires intensive cooling, which would be difficult to achieve in space. Only low-power nuclear engines are known to science today, with several countries already working on the development of more powerful and safer versions. For example, in 2017, NASA and BWXT Nuclear Energy signed a contract on the development of a technology of this kind, which will enable terrestrial spacecraft to reach planets like Saturn in a few months' time. Perhaps even the next generation of people will live to see the day when they can freely travel around our system and cover enormous distances between planets within a matter of a few months. However, we should remember that all the projects mentioned currently exist only in theory, and their realization has equal chances of success or failure. Man will always try to break away from the limits imposed by the surroundings. Sooner or later, one of these attempts is going to be successful. It is quite possible for a breakthrough to take place even this century. Meanwhile, what remains for us to do is to marvel at discoveries in today's physics and to hope that the history of mankind will not end on this planet. The location of this exoplanet would be known to many, or at this point in the video would be guessed by many. It is the triple stellar system Alpha Centauri. The system is made up of 3 components. Interestingly, 2 of them are seen as a single object, which is also one of the brightest dots in our sky. These 2 are Alpha Centauri A and Alpha Centauri B. As for the third component, Alpha Centauri C, It is a very dim red dwarf, and it was this third humble one that caught astronomers' eye. The first two components are located quite close together, while the third one is barely visible. That is the reason why the system is often referred to as a single star. Alpha Centauri never quite leaves the horizon and can be easily seen with the naked eye in such places around the world as Buenos Aires in Argentina or Sydney and Melbourne in Australia. The first two components of the system are very similar to our Sun in their properties. Alpha Centauri A, for example, was the first star whose atmosphere was directly observed. As a result, a thin cold layer was discovered, and this is one of the similarities with the host star of our Earth. The age of the Alpha Centauri system is estimated at 6 billion years, which is essentially 1.5 billion years more than the age of our Sun. The A and B components follow an elliptical orbit around the common mass center, and their orbital period is 79.91 years. As for the third component of the system, generally referred to as Proxima Centauri, it is located about 0.21 light-years away from either of the two stars, and it takes it about 500,000 years to complete a full orbit around them. Proxima Centauri is 4.24 light-years away from the Earth, or 270,000 times further from us than the Sun is. Following some calculations, it was concluded that its actual diameter is about 7 times smaller than that of our Sun, and is just 1.5 times bigger than that of Jupiter. Like many other red dwarfs, this is a flare star, and its luminosity dramatically increases several times in the course of its flaring up. This may well be indicative of the object's impressive age. Proxima Centauri was spotted back in 1915 by the astronomer Robert Innes, who noticed a star moving in a way similar to the other two objects in the system. That is how he came up with the suggestion of its name, Proxima Centauri, which literally translates as the closest. In 1998, the spectrometer on the Hubble Space Telescope registered a planet half an astronomical unit away from Proxima Centauri, but investigations that followed failed to confirm the discovery. Only on the 24th of August 2016 was the European Southern Observatory able to confirm that there was an Earth-like planet in the habitable zone of the star. It was then given the name Proxima Centauri b. First real evidence of this planet's existence was provided by a group of scientists headed by Mikko Tuomi, an astronomer from Finland, in 2013, when they were going through archived data from two spectrometers, namely HARPS and the ultraviolet and visual Echelle spectrograph mounted on the VLT, the Very Large Telescope. In order to confirm the possibility of discovering the exoplanet, in January 2016 a campaign was launched by the European Southern Observatory and was given the name the Pale Red Dot. Several months later, on the 24th of August 2016, the existence of Proxima Centauri b was officially confirmed by a team of scientists headed by the Spanish astronomer Guillem Anglada Escudé and announced by the European Southern Observatory. The planet was detected by the radial velocity method, also known as Doppler spectroscopy. It is an indirect method of planet detection where periodic Doppler shifts in the spectral lines allow one to say whether there is a planet orbiting a star or not. Proxima Centauri b proved to be the closest exoplanet nearest to us. It is located 7.3 million kilometers away from Proxima Centauri, and its orbital period around its host star is completed within 11.2 Earth days. But even though it is comparatively close to its star, the latter is quite dim, and the planet receives just enough heat for the water on its surface to remain in the liquid state rather than turn into perennial ice. The minimal mass of Proxima b is 1.27 that of our Earth. Following the assumption that the planet's rock composition and density are identical to those of the Earth, its radius must measure 1.1 that of our planet. The light received by Proxima b from its parent star is 65% of that received by our Earth from the Sun. The steady-state surface temperature is 234 degrees Kelvin, or 39 degrees Celsius below zero. A couple of years ago, this twin of our Earth's would make for a sensational scientific discovery, and would be assumed to almost certainly be populated by living organisms. But had it been the case and had life forms been discovered on that planet, the video on our channel would definitely bear a different title. As it is, at this point scientists cannot say for sure whether the planet is actually habitable. According to today's estimates, since Proxima Centauri b has supposedly no magnetic field, it receives 60 times more high-energy radiation and 400 times more X-ray radiation than our Earth. In theory, these figures admit of a biosphere where biological fluorescence is a protection mechanism used to shield against ultraviolet radiation flares. This phenomenon is known to be widespread among some species of coral polyps or anthozoa, and is also to be observed on exoplanets orbiting active stars. However, just a year after the planet's discovery, a disconcerting event in the history of the planet destroyed all hopes so cherished by scientists. In March 2017, a powerful flare on Proxima Centauri was registered by astronomers using the Atacama Large Millimeter Array Radio Telescope. The host star's brightness intensified 1,000 times and stayed that way for 10 seconds. Proxima Centauri b would have experienced an overwhelming amount of radiation from this flare, and if there had been any biosphere on that planet, this event would have wiped it out completely. Scientists believe that if flares like that occur regularly, they would have completely stripped the exoplanet of its atmosphere, thus rendering the surface absolutely uninhabitable. It's worth mentioning here that radiation endurance of microorganisms like Deinococcus radiodurans allows us to foster hopes that hypothetically life may yet develop on that planet following a course of evolution of its own. This isn't the end of the Proxima Centauri system's story yet. In 2019, astronomers from the Observatory of Turin announced the discovery of another exoplanet candidate in the star's vicinity. The object was dubbed Proxima Centauri c and may hypothetically boast a mass at least 6 times that of our Earth. Alpha Centauri is currently seen as one of the first destinations for interstellar flights in the future. Even in 2016, preparations for the flight of a nanosatellite driven by laser sails to Alpha Centauri were announced to be in progress. The flight time to the closest star was estimated at 15 years. The name of the project is Breakthrough Starshot, and apart from reaching its planned destination, it has one more mission. Scientists plan first and foremost to prove the feasibility of the concept flights like that are based on. Of course, now it is too early to say anything. Many would argue that there cannot be life on other planets, as too many space factors need to neatly combine to provide favorable conditions. Most scientists, on the other hand, refuse to passively resign to this, and so the search for exoplanets doesn't cease. Sooner or later, telescopes will get advanced to such a point that it will take us just a casual peek through one to be able to tell if there are any developing life forms on a given planet. And all mysteries of exoplanets will be effectively dispersed. And if we really discover nothing with these extra powerful telescopes, the only thing for us to say with any certainty will be how lucky we are to be inhabitants of our Earth. Systems with this number of stars are rather rare. What we see while observing the stars are generally binary systems, that is, systems consisting of 2 objects. As for multiple systems, that is, those made up of 3 or more stars, they are by far rarer. There are 2 varieties of multiple systems, namely optical and physical. Objects in optical systems are located far from each other, but seen from the Earth they appear to be just one star. Objects in physical systems, meanwhile, are actually close together and are bound by gravity. Most physical multiple systems consist of just 3 objects. It is triple systems that account for about 70% of all systems of this kind known to us today. The Castor system, however, is noticeably different from the majority. Each of the 3 main stars in this system is a binary star. Thus, the total number of stars in Castor is 6. It is also highly unlikely that there are stars in areas unobservable to us in Castor's vicinity which are gravitationally bound to this sextuple system. The more components a multiple system contains, the fewer such systems there are in space. This means that systems consisting of 3 and more stars must be extremely rare in the universe. It goes without saying that we are far from possessing all data about multiple systems statistics. That is why we can't but admit that in theory there may be systems with still more components somewhere in deep space. Getting back to the Castor system, this is the second brightest object in the constellation Gemini. It is beaten only by Pollux, an orange-hued giant star. In terms of luminosity in our sky, Castor holds the 23rd place. The system is 50.88 light-years away from our Earth, and its age is estimated at approximately 200 million years. It was discovered back in the 17th century, and even then it was classified as a binary system. And later, astronomers managed to spot several other objects physically bound to it. The first and the main component of the system was dubbed Castor AA. This is a main sequence star of spectral type A15. It is about twice as heavy as our Sun, and its radius is also 2 Sun's radii. The surface temperature on Castor reaches approximately 9,140 degrees Kelvin. At the same time, the object's luminosity is 30 times that of our Sun. The second component's designation is Castor BA. It is of spectral type A25M, and its mass is 1.7 times that of the Sun, with its radius measuring 1.6 that of the Sun. Castor BA orbits its companion star Castor AA. It takes the two objects about 350 years to complete a full orbit around each other. It was later found that the eclipsing variable star YY Geminorum is also physically bound to Castor. It is a star of spectral type M.55e. Its mass is 0.62 that of the Sun, and its radius is 0.76 that of the Sun. That made it the third component in the system, so it was rightfully designated Castor CA. This star follows an elongated elliptical orbit around the system's barycenter. Scientists estimate its orbital period at 14,000 years. As for its location, it is approximately 1,100 astronomical units away from its two companions. Each of these stars is binary, which means that each of them has a secondary companion of its own. Let's look at them. Castor AB is strongly bound to Castor A, and its mass is about half that of the Sun. Castor BB is a star of spectral type M25, and its mass is also about half that of the Sun. Castor CB is a star of spectral type M.55e, and is slightly heavier at 0.57 Sun's mass and with a radius of 0.68 that of the Sun. Castor CB is almost identical with Castor CA in its properties, as the surface temperature of both is approximately 3,820 degrees Kelvin, and their luminosity is less than 10% that of the Sun. All the 6 stars orbit around a common center of mass, or barycenter, and their overall luminosity is 52.4 times that of the Sun. Castor AA and Castor BA are white stars. Interestingly, the former is 30 times and the latter 14 times brighter than the Sun. By contrast, Castor CA and Castor CB are typical red dwarfs. According to scientists, Castor AA and Castor BA are supposed to remain in the main sequence stage for at least several 100 million years. The red dwarfs, meanwhile, like Castor CA and CB, have a much longer expected lifespan. This is due to the slow process of thermonuclear fusion of hydrogen, and so they may last from several billion to tens of trillions of years. Scientists are currently busy looking for exoplanets in the Castor system. However, so far they have not been able to discover as much as a hint of exoplanets in the system. Perhaps the system is too young to have produced any, or else more advanced methods of detection are called for. It is too early to speak about other physical properties of these stars. It is quite difficult to study them because they are optical doubles and seen from the Earth only seem to be close, whereas it is an illusion. That is why special spectrometers are necessary to take care of accurate measurements. We can see all the 6 stars from our Earth as a single object, and it is located in the northern hemisphere in the constellation Gemini. The best time to observe them is in winter and spring. It is easy to locate Castor in the sky, as it is bright enough and can be found near a well-known asterism called the Winter Circle or the Winter Hexagon. This asterism is made up of Pollux, Capella, Aldebaran, Rigel, Sirius and Procyon. It is best seen in the night sky in northern latitudes in the winter time. February is the best month to observe Castor and Pollux. It's worth mentioning that Castor is a star system that leads a group of at least 16 celestial bodies. The point is that these stars move together and have similar velocities, and their age is similar. That is why they have been dubbed by scientists as the Castor Moving Group or Castor Stream. It includes such well-known astronomical objects as Fomalhaut, Vega, Alderamin, Alpha Libri and others. The question of Castor's stellar evolution still remains open. As I've mentioned before, most telescopes are incapable of revealing finer details of these stars, as they're too close together as seen from the Earth. According to some scientists, systems of this kind are formed as a result of a big star split into two components by centrifugal force. Others claim that they originate when one star gravitationally captures the other. There is also a theory of compound nucleus formation that suggests a molecular cloud's fragmentation with stars forming as a result. Then there is a theory involving protostellar disks that suggests sudden cooling of gas in a massive protostellar disk, so several stellar companions may simultaneously originate in one and the same plane following the disk's fragmentation. Be it as it may, most facts indicate that multiple systems originate in one place rather than from scattered sources. In the case of the Castor system, its components are believed to have been formed out of one molecular cloud in the same period. Were a hypothetical exoplanet to find itself in the Castor system, its inhabitants would have enjoyed rather bizarre natural phenomena. For example, the planet would receive light from several stars at the same time, so there would be several sunrises and sunsets a day. At least it seems bizarre and exotic to us, as we live in the light of only one star. If the Sun had a companion with similar parameters, the Earth would get twice as much heat and light with all that it implies, and the sky above us would have a totally different aspect. And it is hard to imagine what a sky with several stars like our Sun would look like. This mind-boggling sight is straight from a world of fantasy. But that's what we would see if we were to find ourselves in the Castor system. This binary system has been on the astronomical map for several decades, and all the while has been thought of as just one super bright star. MY Camelopardalis, or MY Cam for short, is 13,000 light-years away from the Earth. It used to be classified as a variable star. The object aroused interest only as late as in 2014, when a group of Spanish scientists was able to define MY Cam as a binary star system. The discovery was made thanks to a 2.2-meter telescope in the Calar Alto Observatory. Both stars boast a comparatively big mass and are drawn quite close together, with their outer atmospheres almost touching. One of them is 38 masses of our Sun, and the mass of its companion is 32 masses of our Sun. The radius of each measures 700 those of our planet. Just to compare, it's 6 times the radius of our Sun. As for the age of these objects, they're comparatively young and cannot be over 2 million years old. MY Cam may well be called one of the most massive binary star systems known to science. Both objects of the system are hot blue O-type stars. Their rotation speed may reach up to 1 million kilometers per hour, with the surface temperature of each of them as high as 40,000 kelvins. The orbital period around their common center is about 28 hours, which means that both giants complete a full orbit around each other in a bit over a day. Just to compare, our Sun completes one full rotation in 26 days. MY-CAM is also quite bright, which makes it visible even through a common telescope. The star's orbit is a rather narrow one, which is why they are alternately eclipsed practically every day. This explains constant changes in their luminosity. Before this fact became known, scientists used to be confused about the properties of this stellar system. The existence of MY-CAM doesn't seem to be that incredible, considering the fact that most celestial bodies in the Milky Way were formed in big stellar systems whose objects were also variable and eclipsing stars. This means that these objects' overall luminosity may vary from time to time. MY-CAM can be called one of the best-known stellar systems of the kind. In fact, it seems to have been originally formed like this, and has always looked the way we can observe it today. Since the components are in such close proximity, sooner or later they are bound to collide and then merge into one enormous star, whose mass may well reach as much as 60 sun masses. Thanks to theoretical modeling, it is assumed that when stars merge, it is a quick procedure accompanied by a big bang, with incredible amounts of energy released as a result. If this happens with MY-CAM, astronomers will be able to observe this demonstration, confirming the theory that supermassive stars are formed when two less massive objects merge. To date, science has not yet witnessed a merging process of this kind. The possibility of our suns taking part in a similar process is quite negligible. According to today's estimates, a collision of the main star of our system with another star may take place once every 10 to the power of 28 years. But even with such a minuscule chance of this collision, our Earth would be seriously affected were it to take place somewhere close by space standards. If it were to happen within 100 light years from us, our blue planet would be completely devastated. However, at this point there isn't a single star cluster within that range. So far, we have only been able to record the result of two neutron stars' collision. In theory, this process should result in the formation of a neutron star with an even bigger mass, or else it should cause the formation of a black hole. When merging, neutron stars are capable of generating a magnetic field billions of times more powerful than that of the Earth. This process may be accompanied by a gamma-ray flare. That is the most powerful energy emission in the universe known to us. I mentioned it at some point in other videos. However, in spite of the tremendous scale of this phenomenon, astronomers have never been able to directly observe the process of merging stars. One of these events, the GRB 150101 gamma-ray flare, was detected only in 2018. The event made it possible to draw a connection with gravity waves detected back in 2015. Gravity waves are also a result of two neutron stars merging. It looks like something similar awaits MY-CAM as well, and if a planetary system were in its vicinity, it would be a far less serene place to be around in comparison with our planet. The enormous mass of MY-CAM is indicative of its short life, which leads us to assume that intelligent organisms would simply not have had enough time to develop on its hypothetical planets. Besides, as the stellar system grows older, both its components increase in their dimensions. This process brings MY-CAM ever closer to its inevitable destiny of becoming a supermassive stellar giant and then an even heavier neutron star or else a black hole. The MY-CAM system is also peculiar for the fact that it is located in a region of the universe rather densely filled with stars. Regions like that are sometimes referred to as globular star clusters. Star mergers are rather common in areas of this kind, since the number of stars there is by far greater than in our system's proximity. According to the latest estimates, star collisions in globular star clusters occur approximately once every 10,000 years. Unlike MY-CAM, objects like our Sun are sole drifters in a galaxy with only a planetary system for company. However, such celestial objects are not that common in the universe. Sun-like single stars in the Milky Way account only for a measly 2%. Most stars are part of multiple systems. For example, triple star systems are the most common, accounting for about 75% of all observable stars. Most of them have to struggle with the gravity force of their companions throughout their lifetime. This interaction, in its turn, leads to the formation of even larger stellar systems. Most of the supermassive stars known today may at one point have been part of systems with at least one companion of an identical mass. Thanks to frequent eclipses occurring in multiple star systems, scientists are able to investigate the celestial objects in more detail. In the case of MY-CAM, for instance, astrophysicists detected a wide range of spectres of light emanating from it. They went on to use the Doppler effect, thus measuring the star's orbital speeds. With this knowledge, it was safe to maintain that MY-CAM is an exceptional object in space. In the future, this stellar system will enable us to confirm some hypotheses as to the formation of massive stars in our galaxy. When celestial objects like that are discovered, we grow ever stronger in our belief that our universe is an amazing place, concealing an unimaginably large number of as yet unknown phenomena. Each of them poses a hurdle for science, but once it is negotiated, our civilization continues to develop and expand its knowledge about space surrounding us. We will soon get even more information about MY Camelopardalis, as an object with such exciting properties can't but attract attention of scientists all over the world. There is no knowing what features of star formation we will be aware of at that time, but it is safe enough to say even now that these remote gigantic stars will never cease to amaze us. The term stellar evolution in astronomy refers to the sequence of changes that a star undergoes throughout its entire life. This process largely depends on the object's initial mass, and may take anything from several million to tens of billions of years. As a rule, a star originates from a cloud of cold, low-pressure interstellar gas. Due to gravitational instability, the cloud compresses and eventually slowly assumes a spherical shape. During the compression process, the gravitational field energy is transformed into heat and radiation, with the temperature of the young star gradually going up. The duration of this stage depends directly on the star's initial mass. With the heaviest stars, it may take about 100,000 years, and with the lightest ones, the phase may last up to several billion years. Our Sun's mass, for instance, is comparatively small, and so it remained in this first phase for approximately 110 million years. In the next phase, after a sufficiently high temperature has been reached in the core, thermonuclear fusion takes place inside the star and the compression ceases. After this, the processes taking place at the core become the star's only energy source, and thus a young star, which is also called a protostar, becomes a main sequence star. This is the starting point for calculating a star's age, as this phase accounts for approximately 90% of its life cycle. Our Sun, for example, will remain in the main sequence stage for approximately 11.5 billion years. When a star enters its main sequence stage, its chemical composition is still very close to interstellar environment and is 91% hydrogen. At the same time, the process of hydrogen transforming into helium is constantly in progress inside the star. As a result, the core compresses and gains in density, which gradually increases the rate of chemical reactions. It leads to noticeable changes in the star's properties. For example, the luminosity of our Sun in the main sequence stage accounted for only 70% of its luminosity today. By the time this stage is over, the luminosity is going to be 2.2 times that of today. It should be mentioned that not all stars make it to the main sequence stage. The exceptions known to science today are referred to as cold and hot subdwarfs. These objects are very similar to main sequence stars, but they do differ from them. Thus, by contrast, subdwarfs are not rich in heavy elements and are not so luminous. The final phase for main sequence stars also depends on their mass. Generally, a star either discards its outer coat, thus becoming a white dwarf, or goes supernova to later become a neutron star or a black hole. A supernova is a phenomenon when a star's luminosity dramatically intensifies, with great amounts of energy released during the process. After that, the flare slowly fades. This explosion is accompanied by emissions of great amounts of matter from the outer coat. The remaining matter in the core of the star gone supernova generally forms a compact object, either a neutron star or a black hole. Apart from everything else, the matter released in the course of a supernova event contains products of thermonuclear synthesis. It is thanks to these elements that the universe is able to evolutionize chemistry-wise. If a star's mass doesn't quite reach 8 sun masses, however, this main sequence star will end up being a white dwarf. That is, an object which is a hot celestial body of small dimensions and a high density. For instance, in the case with our Sun, when the time comes for it to go through this phase, it is going to become 100 times smaller than it is now. White dwarfs do not generate energy and are luminous only on account of their high temperature. Even though the hottest white dwarfs' surfaces may be as scorching as 70,000 kelvins, due to their small size, their luminosity is not that great. As for their average density, it is almost 1,000,000 times that of the regular density of main sequence stars. These objects consist for the most part of a plasma of nuclei and electrons, and are completely devoid of thermonuclear energy sources, which is why they gradually cool off and assume a red hue. Sirius B is the closest white dwarf to us that we currently know of, and it is 8.6 light-years away. This object's mass is give or take that of the Sun and is considered to be one of the most massive white dwarfs known today. Its volume is 1/1,000,000th of that of the Sun, and its dimensions are identical to those of our Earth. Sirius B is believed to have become a white dwarf approximately 120 million years ago, with the initial mass of the star in its main sequence phase having been 5 sun masses. Today, it is posited that these objects account for 3 to 10% of the overall stellar population of our galaxy, according to different estimates. Over 97% of the stars known today are eventually destined to become white dwarfs. As time goes by, these objects are bound to cool off and fade. Eventually, all celestial bodies of this variety will become black dwarfs, which implies that they will completely cease to emit any visible light. This process takes scores of billions of years. That is why to date science hasn't had a chance to observe any of these objects. The universe is considered to be too young to have produced any black dwarfs at this point, but scientists have already managed to spot objects quite similar to them, whose temperature has gone down lower than 4,000 kelvins. These objects are white dwarfs WD 0346+246 and DESS J110-217. A black dwarf is what most stars look like at the final stage of their evolution. Its mass is quite identical to that of a white dwarf. According to today's models demonstrating cooling of these bodies, white dwarfs formed in the course of the evolution of the first generation of stars are supposed to have a temperature of approximately 3,200 kelvins and to appear as rather dim objects. For all we know, these celestial bodies could be part of the universe's hidden mass components. For a white dwarf to cool off to the temperature as low as 5 kelvins, it may take approximately 1 quadrillion years. In theory, when black dwarfs cool off completely, the process of dark matter annihilation becomes very important for their existence. This phenomenon hasn't been directly observed in the universe yet, although it is thought that in the course of annihilation, particles of dark matter will form ordinary photons and emit light visible through a telescope. Without allowing for this phenomenon, Black dwarfs are believed to cool off and fade to the point where their temperature equals the background temperature of the universe. However, in theory, thanks to the energy derived from dark matter annihilation, black dwarfs may well continue to radiate energy for a considerably longer period, and thus enjoy their luminosity longer. The process of dark matter annihilation in these objects is thought to continue for as long as the galactic halo remains whole, and that means for over a septillion years. After that, dark matter annihilation gradually ceases, and only then will black dwarfs cool off completely. It is likely that mankind will never be able to discover objects of this kind, as the main period of their life takes place in the phase and the life of our universe which will come after the one we're in at the moment. The period we live in is a star epoch, that is the period where stars are still born quite actively. This epoch will last up until the point when the galaxies will deplete all of their interstellar gas. After that, it will be the turn of low-mass stars like our Sun to fade. Following that, a long period of disintegration will begin, when white, brown and black dwarfs are the main objects populating the universe. At the next stage, the epoch of black holes, all matter in the universe will be transformed into elementary or subatomic particles, with the remaining black dwarfs getting sucked in by black holes or completely disintegrating. The final stage in the life of the universe is supposed to be the epoch of eternal darkness, where there won't be any energy sources whatsoever in space. The overall temperature in the universe will reach absolute zero. Space will gradually expand, and in the light of the last and rare black holes, in about 1 Gogol years, our world will come to its gloomy end. On our journey, we have seen only a handful of space objects, but life is too short to visit them all, and the life of the universe at that. But this doesn't interfere with our motivation to carry on studying things in space, which means that there is still a great load of discoveries waiting to be made.